Hi everyone, welcome back to the channel. Today we are diving into how you can deploy a deep learning model, specifically, let's say, like an classifier. This can be applicable to a computer vision model too. But here in this tutorial, I'm going to describe about an LSTM classifier. A serverless function using Lambda is a serverless function of AWS, and SAM is a framework on AWS that can be used for deploying to the serverless component of Lambda. Whether you are a developer, ML enthusiast, or someone who is just exploring the serverless infrastructure, I hope you will love watching this video. Okay, so now let's go. So what were we building? So the topic is deploying a neural network model or an LSTM model to AWS Lambda through SAM deployment techniques. So at the heart of the project, we'll have a very simple neural network model built with PyTorch. It classifies sentences, and we'll deploy this to AWS Lambda using the help of SAM. So what is SAM? SAM is a serverless application model. The model is exposed to an API gateway endpoint. So essentially, we are going to package this intelligence in a function that scales automatically and costs nothing when idle. So it's a very cost effective way of doing this. So let's look at the prerequisites. So for the prerequisites, you definitely need an AWS account, the AWS command line interface. This you have to install into your local system, and or you can configure it with AWS Service. I would ask you to install. It's best to install it on your local system, and this can be actually worked with, or you can access this to VS Code. An AWS Serverless Application Model or SAM. So these are, if you just search this, or the links are given in my, I'll be providing this PDF at the end. So you can just go into that link and download the SAM. Okay. So that should be installed, and of course, this is going to go through Docker. So you definitely need Docker service to be running, or a Docker desktop application to be running. Okay, so let's go over. We'll use a simple LSTM-based language model to classify sentences, as we mentioned earlier. We use the AWS SAM CLI to create serverless endpoints with an Amazon API Gateway. The following diagram illustrates how the architecture is used. So a client calls an API Gateway, and then API Gateway in turn calls the AWS Lambda Inference endpoint. And this is very simple architecture that we are going to work with. Okay, so let's go ahead and start building this application. So very important. Once you have installed your SAM as well as your AWS CLIs, you would actually run this command SAM init. Okay. Enter one for your template, which is a hello world example template. I have also provided a GitHub repo that I'll provide at the end of this lecture, or you can also copy it from the YouTube video link. Then enter one for hello world example. Then the numbers might change a little bit, at least on the Python end, because of the version. So you can use 3.12 or 3.13. So I did use 3.13, I think, at the end. That should be given in the GitHub repo. So you can enable or disable your X-ray or your logging structure for AWS. That's up to you. So our package type should be always image. So it will give you two options, zip or image. So you should be using the image option because we are going to deploy it through ECR, which is the repository, Amazon's Docker repository. Okay, so let's go over and check the folder structure. So let's say I created a project which is named SAM test. Okay, and then you will see all these .aws folder, events folder, then a hello world folder, tests folder. So at this time, we are mostly focused about our hello world model, which consists of the app.py or Docker file requirements, as well as the webs file, which for the test classifier. Okay. So yeah, so this is how your folder structure will look like. That's provided with the README. So what we will change right now at this point is the app.py, which will contain a Lambda handler as well as the codes that are useful for calling our model. Then a Docker file and definitely requirements.txt. You don't need to mention PyTorch because once you are already using Python 3.12 or 3.13, AWS will install the PyTorch library in your path. So if it's other libraries like transformers, if you're using a Hugging Face and all, then you have to mention those into a requirements.txt. So most of your common libraries like pandas, PyTorch, uh, Skippy, and these things, or a scalar scikit-learn will always be there with the PyTorch actually. So we don't have to mention those in the requirements.txt. Okay, so then moving on. Okay, so just to give you a small brief idea about how this text classifier is. So your model should, I presume, should be more complicated than this one. So I just used this very simple text classifier which has an embedding. So it has vocabulary search with an embedding dimension. And then we are calling the NN, so neural network module. We are calling the neural network module, which has the LSTM functionality. So which extracts sequential patterns and then it maps the LSTM output to two class logics. So it's 0 or 1. So it's just a class simple binary classifier. Okay. So that's the reason you can see the LSTM output patterns are then passed to an NN linear model or a dense model, and then you're making a binary classification. Okay. Okay. So then moving over, pre-process and create a toy data set. So as I mentioned, I'm using a very simple model and I have provided a very simple set of toy data set. So I've created word to vec or word to numbers, as you would say, kind of function over here. And then we are encoding this. We convert a sentence into a list of integer indices using this vocabulary. So just a very simple encoded sentence function. I presume your code will be much more difficult than this one. Okay, so once these kind of models, you can have a lot of pre-processing steps available to this. But once these are implemented, now comes the part of the AWS configuration. So let's start clean in a PowerShell or in a VS Code. You can I'll be providing a snapshot of this video later on in this tutorial. But in a PowerShell, I would suggest you go over to a PowerShell in a VS Code. We can clear our old AWS credentials and then reconfigure using an AWS config. Okay. So let's just clean up that. So if you check what is the AWS configure list, so you might have an old existing credential. So it's a good way to always clean it up, especially if you have worked on your AWS configuration for a different project, and your access keys or access ID were different or session tokens were different. It always it keeps it in your bash rc and all those things. So just good to remove all those credentials. Okay, so you can use all these commands to clear your credentials at first, and then you can check if those have been so you can again check if those have been cleaned. So if I now have cleaned all those existing credentials and then I do the AWS configure list, you can see its profile, access key, secret, region, all these are set to none at this point. Okay, so think okay. So now you need to configure this again. So AWS config. So we are configuring it again. So you provide your access key ID, your secret ID, those comes from your AWS account. Default region name US East 1, and you can also have it as US East 2, whichever region you want to put this, you can just modify it. Default output format, you can just press it to none. Okay, at this one. Okay. So now in the step two, we will basically try to write the Lambda handler. So whenever you are writing a Lambda handler within the app.py, you are actually using an event and context. Okay. So it's designed to run an AWS Lambda environment. So that's the serverless environment. And the event is basically a JSON body containing a sentence for me in this case. Okay. You can also pass an image if you are you are working with the computer vision model. Okay. So you mentioned the you mentioned the path of your or the width path. Okay. Then because it's like a lambda function, we are not using GPU here, so we'll just mention the torch device to be CPU. Okay. Okay. And then let's go over to a little bit more about how the Lambda handler works. So as you can see over here, we are loading the text classifier model, and then we are mapping it to the CPU device or to the torch device, and we are putting it to the evaluation mode. Okay. So pre-process and encode the sentence, convert input string into tensor for inference. So that's what exactly this is doing. So whatever sentence you have provided through your maybe a postman service or from your front end, this is where it's encoded. Okay. So add batch dimension, so clone detach, and then we add the dimension, predict the label torch argmax output item, dot item, so this will give you 0 and 1 basically. So if the model predicts the class 1, then you will get the response as status code 200, and the body, the prediction of class 1. The prediction is class 1. Okay. So that's how the output works. Now the second thing, the step 3 is to set up your Docker. So Docker file is very important. So pull the base image with Python 3.12 as a runtime for your Lambda. So this will pull all those libraries along with PyTorch. So this purpose is start from an official AWS Lambda base image with Python 3.12 install. This image is optimized to run Python functions as AWS Lambda expects. So it's best to use AWS's official Python library for this case. Copy the earlier created requirements file. So copy requirements.txt. You don't need to update it because right now we are not using anything or any library which was not provided with Python 3.12. So this adds a requirement into your Docker image. So very similar to what Docker file actually works. So run Python 3.12 slash m pip installs, and this is actually, of course, installing all your requirements. Then here it's very important, make a directory model. So create a model directory inside the container to store the model files or other assets. So even though you have provided the path of the wets file, so this is where we are actually putting the wets file. It is important to create a model file which can be actually put into or put into the container. So then you copy app.py to the Docker file, the Docker container. Copy this width image to model, and which actually stays within the Docker container. So what is this doing? Adds your main Python script app.py and the pre-trained models into the image. Okay. Okay, and finally you have to run the Docker file. So set the CMD to your handler. So app.lambda handler. Okay, so just simply tells the lambda function which function to invoke. Right. So now, once this is done, you can now start building it. So the first things is SAM build. So this is a kind of an output that you can that you can expect when you run the sample. So it's locally building your Docker image. So at this point, make sure that your Docker container or Docker desktop application is actually running. So it all the steps that are provided in your Docker file is what is happening over here. So step one, two, three is whatever it's how it's creating those images based on your Docker file commands actually. So move over. So this is all the steps, and then finally it has reached CMD. So this is where it is. Then it is built successfully, and it has also tagged it as so it also provided a tag. So if you are familiar with Docker, so Docker also provides a tag at the end of it. So this is how you can know the image along with the image tag, right? This is how you can call it. So finally, we use now deploy it to the AWS Lambda. So you'd use SAM deploy guided. So dash dash guided. So why do you use guided? Because then it asks you all these commands. So do you take, so the name of my stack is SAM test. Do I keep it the same way? Yes, of course. AWS region is US East. So if you want to make it to US East too, so you can just use it, or any other region of your choice, you have to provide it. So I have just taken I did take the default version of it. Then it will also ask you for a bunch of confirmations, confirm changes before deploy. So before deploy, do you need to check through this whatever it has done? So you can say yes. So this is very important that SAM needs permission to be able to create roles to connect to the resource in your template. So role creation, so you're giving the permission to SAM, otherwise it cannot create any resources in AWS if you haven't provided the role, the creation role to SAM. So then otherwise it cannot create it, so you should always put it to yes. Okay, otherwise you have to put other AWS policies so that it can work properly. Okay. Now, you can also expect few of these options coming over. So do you want to disable rollback? It depends on you. I put no, I don't want to disable it. So if it's not working for some reason, then it just go back to the previous one. Save arguments, you can keep, you can take it whatever it is, or SAM configuration, samconfig.toml. So this is also provided while you were using SAM init and creating the beginning folder structure. And then it creates and manages. So because you have given every permission to SAM to create S3 bucket, ECR and things like that. So it did create a bucket where it is going to store all the libraries. Okay. Okay, so stack name. So this has also created a stack name within ECR, and then it saved it. So it just does everything for you. And finally, you will be so after this deployment is successfully completed, you will actually be able to test this. So I'll be showing you how a snapshot of how this is working, and of course the testing part. So at the end, I would really appreciate if you subscribe to our YouTube channel, and we always do some weekend classes, and this is where we think we can learn, build, and grow together.